Hello students, welcome back to this lecture series. In previous video, I had explained PSK, that is phase shift keying. In this video, we will see about PCM, that is pulse coded modulation. So let's start the session. Let's see today's course outline. Firstly, we will discuss about the introduction of PCM modulation, various steps like sampling, quantization and encoding. After that, we will see its various applications. So, let's start with the introduction part. Modulation is the process of varying one or more parameters of a carrier signal in accordance with the instantaneous values of the message signal. The message signal is the signal which is being transmitted for communication, and the carrier signal is a high frequency signal which has no data, but it is used for long distance transmission. There are many modulation techniques which are classified according to the type of modulation which is employed. PCM is a digital modulation technique. A signal is pulse code modulated to convert its analog information into a binary sequence, that is in ones and zeros. The output of a PCM will resemble in a binary sequence. The figure shows an example of PCM output with respect to the instantaneous values given in a sine wave. Here you can see a sinusoidal analog information waveform which is provided to the input part of the PCM. And after processing this information signal, it is converted to the digital waveform or digital signal. Let's see how PCM works. PCM encoder performs mainly three functions. First is sampling, second is quantizing, and third is encoding. So let's see each functions one by one. Sampling. It is defined as the process of measuring the instantaneous values of continuous time signal in a discrete form. When a source generates an analog signal, and if that has to be digitized having ones or zeros, that is high or low, the signal has to be discretized in time. This discretization of analog signal is called as sampling. As you can see here in the diagram, sample is a piece of data taken from the whole data which is continuous in the time domain. The number of pulses per second is called as sampling rate. The method of sampling chooses a few points on the analog signal, and then these points are joined to round off the value to a near stabilized value. Such a process is called as quantization. The levels obtained are called quantization levels. Here we are using uniform quantization. Here in this diagram we are dividing the maximum value of the analog signal into a fixed number of levels in order to convert the sample data into binary codes. Let the amplitude level varies between 0 to 5 volt, and let I am representing it by 3 bits. Then total number of levels which is required is 2 to the power 3, that is equal to 8. So the distance between various levels will be 5 minus 0 divided by 8, which is equal to 5 by 8, and this is equal to 0.625 volts. So the first level will be at 0.625 volt, then the second level will be at 0.625 plus 0.625, that is equal to 1.25 volt. Third level will be at 1.25 plus 0.625, which equals to 1.875 volt. Fourth level will be at 2.5 volt. Similarly, fifth level at 3.125, sixth level at 3.75 volt, and seventh at 4.375, and lastly the eighth at 5 volt. Next process is encoding. It is a process of representing the sampled values as a binary number in the range of 0 to n. The value of n is chosen as a power of 2. In this figure, the range is 0 to 7. As you can see here in the diagram, from the quantization we get total 8 levels. Now for assigning them unique values we are using 3 bits. The level 0 we assign 000. For the level 1 we assign 001. For level 2 we will assign 010. For level 3 011. For level 4 100. For level 5 this is 101. For level 6 it is 110, and lastly for 7th level we will assign 111. Now you can see in the figure, according to the bit sequence, these binary values will be transmitted with square waves, which represents digital signal over the digital channel. Applications of PCM. It is generally used in digital telephone systems. It is also used in electronic musical keyboards. It is also used for digital audio in computers and CDs. Lastly, I have some questions for you all. First, explain PCM in detail with proper diagram. Next is explain sampling phase of PCM. Third, explain quantization phase of the PCM. That's all for today's session. We will meet soon with next video lecture. Thank you for watching the video.